The video is on?
Yeah.
All right. So we're going to look at rotational. Now, until this time, we had two, we've already talked about the linear. So let me do some comparison to help. And you see, let me block this way and see how we can, let's caption here this one, linear. And let me prove here both, all right? And let's call here rotational. Rotational motion. So this is your linear motion, and that is your rotational motion. Now, when we're talking about linear, we talk about what? Distance, right, and displacement. So with distance, we usually represent it as, let's say, S. Okay? Now, in rotation, we don't talk about distance. What we do is we talk about angles. Is that clear? You see the difference? Mm-hmm. Now, before that, I want us to look at something. When you go through, if you have your circle that way, from the center of the circle to any point on the circumference is what we call what? Your radius, right? So, if this moves at an angle, a small angle, here will be your what? Your theta, that's your angle. Is that clear? And it moves a small distance, let's call it S. Now, see, you have your distance over here, you have your what? Your angle over here. So, the link between that is going to be R theta. You see that? Next, when it goes through a whole circle, we call it one revolution. And one revolution is the same thing as what? 360 degrees. Which is the same thing as 2 pi radian or 2 pi rad. So, we could either measure our units in what? Revolutions, in degrees, and or what? Rads. Do you understand? So, but here, our unit is always in what? In meters. Is that clear? Now, you got to take note. I'm breaking this thing down because it confuses a lot of students. So you got to take note of it. Now, we said that velocity was what? This displacement or distance over what? Time. Is that clear? We call it linear velocity or velocity. Now, there's going to be its match here. And its match is what we call angular velocity. And angular velocity is also what? The angle divided by time. Is that clear? Now, the thing you got to understand is this. The units might be, there's a similarity in units. Here we say it is meters per second. Here we say it is rad per what? Per second. You see the similarities. Now, in between linear and rotational, your V is equals to R what? Your angular what? Velocity. Now, this is velocity, this is angular velocity. Wiggly W. That's how some of my students, past students, always call it wiggly W. Omega. It is what? Your angle divided by what? Your time. The next thing we did was acceleration. And we said acceleration was what? Your velocity over time. Is that clear? Now, here we have angular acceleration, alpha. Watch. This divided by time is velocity. This divided by time is what? Acceleration. So this divided by time is also what? Your angular what? Your angular acceleration. So this, you just write angular velocity and angular what? Acceleration. This is your angle. We're talking about angles. So angle angular velocity, angular acceleration. So the units here, the unit for this one is what? Meters per second squared, and here is going to be rad per what? Second squared. You see the similarities? Now, so to link these two, we have your acceleration is equal to, then we can have r dash. Is that clear? Also, when we go a step further, we have something we call the centripetal acceleration, and this is equal to the velocity squared over r. We're going to look at this. It is these two cases also. This one also represents something going in a circular motion. That's why I kept it here. We're going to look at it later when we start talking about forces. Now, we want to step down and look at some other factors. Now, when we say mass in linear, it is called inertia in rotational. Is that clear? So mass is what? Inertia, right? Next, the next thing we need to understand is, for instance, let's use force. We say force is equal to mass times what? Acceleration. In rotational motion, we talk about torque. Is that clear? And torque is, what is the mass equivalent here? It is what? Inertia, right? And what is the acceleration equivalent? It is what? Angular acceleration. Is that clear? Here, there is a change in the link between force and what? And torque. Because when we look at torque, we say torque is the force times the perpendicular distance, r. Is that clear? So torque is the force times the what? The perpendicular distance. And this place, the unit is a little bit different. The unit here is Newton meter. That is the unit for torque. Is that clear? So, the other thing I want you to understand is momentum, the one we just did. We said momentum, P, is equal to mass times what? Velocity. Right? In circular motion or rotational motion, we call it angular momentum. It's L. And angular momentum, mass is what? Inertia. Velocity is what? Angular what? Velocity. Do you understand? So, if you are able to link the linear with the rotational, you will find out what? There is a similarity or something common among them. Is that clear? Are we good? So, take note. As we go through the PowerPoint, you will see very well why this one is that way. Now, in linear motion, we say what? We should push with what? A force, right? In rotational, we say what? You should tighten something what? Apply what? Torque in tightening it. Is that clear? Are we good? Kimberly?
Yeah.
You're good, right? So this is the introduction of what do you call it? Our rotational motion or circular motion. What we would do is we would then put a flash on it with a PowerPoint. Is that clear? All right, we can stop it.